Alrighty. So you've got two sheets in front of you. Now, for most of you guys should have your tracing paper by this point, and I mentioned how you really wanted to try to get that transferred. You want to work on your tracing paper, okay? Because that's what's going to be the most flexible. It's going to allow you to erase really easily. It's going to be the most workable surface that you're going to be able to use. If for whatever reason you have forgotten it and all you have is just your box, go ahead, get started, fill in the box. When you trace your box, remember to use the inside of the lines, you're going to trace all of that stuff that you've already been figuring out. And you can just basically transfer that to your tracing paper. But remember, you don't want to keep working on this. I'm going to work on this specifically because it shows up well on the projector. That's why I'm not using the tracing paper. Tracing paper is a little harder to see. I am going to have to bounce back and forth because these sheets are nice and big. I've already got all my halves, quarters, and thirds all marked out, so you can see, make it a little bit darker. You can see the quarters, the halves, the thirds, etc. You can see all of my marks going around the perimeter. For all of the CFOG guests, this is how we go about the drawing process. When we teach you how to draw, we do not teach you all loosey-goosey. You don't come into the class and just be like, hey, we're just gonna draw, and you'll just kind of stumble your way through this process. That's not how we do it. We teach you the actual viable method for how to draw in a very mathematical, in a very structural way. The beauty of it is when you leave the drawing class, you have a systematic step-by-step way of drawing anything that you can see. And it's an actual skill you can walk away with. You should be able to walk away from this class being able to articulate to someone else, this is how you draw. Because let's face it, at this point, if you haven't been through a course like this, if you were to try to explain to someone how do you draw, how would you put that into words? Well, you move the pencil around the paper and you try to make these shapes kind of like the shapes that you see. It's somewhat obtuse, it's somewhat abstract. So this breaks it down into a very, very step-by-step approach. It's all based on proportions. In order to draw this big ship down into this box, which is smaller than this one, all we need to do is be able to scale it down. Just scale everything down in proportion, okay? So we do that by comparing and doing a lot of comparing. We have these measurements along the sides to basically give us a starting position. This box, this photograph, where all of the ink is, the height and width of this photograph is proportional to this box here. They're two different sizes, but they're proportional to each other. This has literally just been shrunk down. That's the only difference. It's just been shrunk down. And that's what we want to do with the rest of the drawing. So class, for all my students here, where do you want to begin? So I would begin here with the ship. You might begin by figuring out how high up the water is. You might kind of plot out where the land is in the background as a general shape. But most of your time you want to spend here in the ship. When it comes to all of the ocean waves and it comes to these clouds, that's going to be a little bit of interpretation. We're going to do our best to match it, but we're going to have to find a way of using a line, something that just generally demarcates two regions, to show fluffy clouds. There's ways that we can do that and techniques we can use without doing any kind of shading. For the CFOL students, for this project, we're not doing any shading. We're going to leave it as just a line drawing. If you would like to see what this kind of drawing looks like when it's all done, the classroom that is literally right across the hall over here, it's our drawing lab. There's a whole row of felt boards, like fabric boards where you pin stuff up. We have one of these boats up on display there, so you can kind of see what their intended end result is supposed to be, as well as some of the other projects that are coming down the road for these students. There's some great examples of what they're going to look like, so be sure to go check out those boards. So always work from big to small, okay? Work from big to small. So we look at something like a sail here. This is just a big triangle. I would start by finding the triangle. Find this point, and this point here. Calculate where those three are. Then, when you need to connect the dots from here to here, all you need is you just need to make a little bit of a curved line, okay? And you don't have to plot that out, okay? You'll be smart enough to figure that out, okay? If you've got A and B here, just give that a slight curve. Now, what about all of these wrinkles in here? All of that little detail, things that we would call texture, that's where we're going to get into kind of an interpretive quality, okay? That's where we're going to talk about, with all of these waves and these clouds, the interpretation. So focus mostly on your time for the next week and a half or so on the structural elements, okay? The primary shapes. The shapes of each of these sails. Where's my pointer here? So each of the corners, the apex of the curve, and the outside edge. Don't worry about these lines going through it. Don't worry about the stitching, the quilting, or any of those pieces. That's just a lot of detail work in between, okay? A lot of that we won't have to measure nearly as much, but we want to make sure we get the sail the right size and in the right place. Focus on getting the mast going down, getting the cross beams. For all of this rigging in here, that rigging doesn't really have any width to it, because once we draw, the literal width of our graphite pencil will be the thickness of these ropes. So we don't need a left side and right side, we just need to calculate where's the top and where's the bottom. And if it's perfectly straight, you are more than welcome to use a ruler or a straight edge to draw that straight line. Just be conscious, some of these have some slack to them, or they're bowed, or they're kind of curving in a little bit. So make sure that you're matching that as well, because they're not all perfectly straight, but a good number of them. Focus on the shape of the ship. Get the overall shape of the ship. You've got nice large shapes like this. Get that shape in there. Figure out the distance of these. You've got the second railing here. Figure out how high that goes. What is the distance from the bottom to the boats? From the side to the side, from the side to the side. Figure out all of the big shapes first. Once we've got what almost looks like a piece of clip art, it's gonna be like a clip art sailboat. Once we've got that in place, I know I should never use the word clip art in an art class. Like, you don't want to compare anything to clip art, but you get the idea. A super simple, like a coloring book, like a super simplified version of it. Then we move on to the next layer of detail. We'll say, now what are the next largest shapes? Okay, well look here inside the boat. We've got all of these, all of the structures in here. We got this big drum here. We're gonna start trying to translate those pieces. We get all of these kind of back pieces that are being somewhat obscured. Flags up in here, flag here, flag here. We want to start then identifying those smaller structures and putting those into place. And you build, you build, and build, and build. That way, something terrible happens on that last weekend, you unexpectedly run out of time, you know it's not gonna be excused, what are you gonna do? Well, you'll have the primary shapes done. Because remember, when we talk about our points, the biggest shapes carry the most weight, okay? The very first thing I'm gonna ask when I look at the boat is the boat big enough, small enough, and is it in the right place? This is a basic question. Is the boat the right size, and is it where it's supposed to be? Then I'm just gonna look at the next. Is the hull the right size? Are these the right size? Are all of these sails the right size and in the right place? I care about that way more than if this little stitched line is too far to the left or too far to the right. It's important, but not as important, okay? So you gotta learn to prioritize and prioritize your time. Don't work in one small section here and say, okay, here's the front of my hull, and I have every string, and I have this piece here, and this piece here, and I got this string and this string, and I've got all these little highlights that run across here, you know, trying to be 100% perfect inch by inch as you go. That's not a productive way to work, and it's not gonna be good for the workplace either, because you never know when your boss is gonna come and say, hey, in whatever state it is, I need it right now. Even if it's not done, just give me what you got. You don't want to give them a perfectly drawn, you know, little section. You want to have a basic layout, because at least then he can go into a meeting and say, this is our general composition. Okay, this is, you know, we've got a basic boat here. We're gonna have some land in the back. We'll have some compositional clouds. It's the basic idea that we're going with, you know, because he doesn't need all that rigging for that conversation. So really in all of your artwork, always work from big to small. Take care of those details last. So let's go ahead and just start finding some points. Now again, I don't have these memorized, so we're just gonna have to hunt for them and just see what works, okay? We can go from the knowns to the unknowns, or the unknowns to the knowns. Doesn't matter. Let's go ahead and start here with our source. I have a nice little dowel rod here. This is not for discipline, although it sounds like it should be. Sounds a little vicious. This is just so you guys can see a little bit better than that mechanical pencil. So, you know, I want to focus on this area in here if I can, trying to figure out where the farthest extremes of a lot of this boat are. So, you know, you can follow a plumb line up. See, if we follow a third, we'll see that this is inside that third region. But let's just see if we can figure out how far over the far left of this boat is from the side. There's a couple ways, of course. We could grab the whole distance from the far left to the boat, grab that whole distance, and then we can start comparing it to our known measurements. In this case, it's anything that we have here on the side. because the height and width are the only measurements we have to start with. 1, 2, 3. So this is a very big distance. This is a massive distance. So it's not going to fit into anything super nicely. And we know, ideally, we always want to put small things into big things. We've learned that already. So instead of taking that giant measurement from here to here and trying to compare it to these, let's take some of these smaller measurements and see if we can put them into here. So while this was an unknown into the known measurements, we're going to take our known measurements and see how many times they fit into this unknown, okay? Because that's all that matters, is that somehow in that little equation, you have some known measurements. And remember, all your known measurements are whatever you have figured out over here. In this case, height, width, half the height, half the width, quarter of the heights, quarter of the width, third of the heights, third of the widths, okay? That's what we have figured out so far. So let's just capture some of these and just see what we get. Maybe I'll try this 1/3 to 1/2 mark. See what I get. 1, 2, about 2.5. About 2.5. So if I take this distance, which you cannot see because this is too low, if I take this distance here between the 1/3 and the 1/2, if I take this distance and I start counting across, 1, 2, it's about 2.5 or so. Let's see if we can find something better. See if we can find anything that goes in nice and evenly. And again, it may not. The first part is always the hardest because we have to do a lot of hunting. Let's see if I can. See, you can't see that one. This is actually too long. I was like, oh, I need it nice and long. This is actually too long. 1, 2, 3, 4. About 4 2/3. Not ideal, but it could work. Remember, the height will be very different from the width measurements, so we can give them a try too. 1, 2, 3. It's about 3 1/4. So nothing super nice. So let's try this other side. Let's see if this other side fits into anything really well. If I follow this 1/3 line straight up, we can see that it's just on the inside. So that's pretty nice. Just on the inside with the 1/3. But let's try some of these other measurements and see what we get. 1, 2, 3, not quite 3. Let's try this one. 1, it looks like that might be 2. Let's check that one. 1, 2. So I'm gonna say that is our 2. It should work just fine. 1, 2. Yep. So the distance on our width down here at the bottom, the distance from the 1/2 mark to the 1/3 mark goes to the front of the ship, to the side of the picture plane 2 times. 2 times. So all we need to do to translate that now is to work that in the opposite direction. We just need to go and take the 1/2 to the 1/3, put that in 2 times coming from that right side. So set this aside, come back over here. You can see here is that 1/2 and that 1/3. It exists over on our source as much as it exists over here. That's what makes it a known measurement. So we go ahead and pick up that known measurement right here. Make sure we get that. For all of the CFA students, when I pick up a measurement, I'm using my pencil or that dowel rod as a measuring device, using the tip of the graphite and the tip of my nail on the pencil to capture a distance, and that's what I'm using to compare to others. And all I'm trying to figure out is how much does this space fit into another space? Then I just come over to my drawing, take the space, divide it down, and put it into place. Drawing is not very complicated. Drawing like this it's not that hard, it's just very abstract. It's not a way that you are ever used to thinking because you've never been asked to think like this before. But once you get over that hurdle, then it really is just a very mechanical process. All we're gonna do is basically find a bunch of dots, a coordinate point. Think about a map. You know, if you wanted to find a place on a map, what would you need? You would need longitude and latitude, a vertical position and a horizontal position. If you have both of those, you can find any point on a map. It's the same thing here. We're gonna figure out how far over, how far up, that's gonna give us a point. And if I have multiple points, all I have to do is connect the dots. We're basically making our own connect the dots here. That's really all we're doing. So taking the 1/2 to the 1/3, coming to the side. This is not the most ergonomic way of doing this. backwards. Okay, so there's 2. So here's my half to the third, fitting in 2 times from the right, and I'm going to place a little X. Now remember, this is only how far over the boat is, okay? That's just how far over. So that's letting us know where we are on this horizontal axis. But we have no idea how high to make it yet. We don't know where it sits on the vertical. So that's the next thing we have to figure out. So remember, when we make our first mark over here, make that an X, and just guess as to where you think it is on the other axis. So we did a horizontal, so we're guessing on the vertical. Now we'll solve for the vertical. So let's go ahead, take that space from the bottom. Be very conscious of where it is you're putting it. In this case, I'm going to put it on the actual hull of the ship. I'm going to ignore the little splash of water that's there. I'm going to grab that measurement. So it's coming straight from the bottom, from here to here. And I'm going to see what this fits into. It is just a touch more than a third there. 1, 2, 3, 4, 5. Looking to see if this fits into anything really nice and neat. A little shy of our half. 1, 2, 3. Might be it right there. One, 2, 3. 1, 2, 3. So from this quarter to 1/3 on my vertical, from these 2 points, if I divide that into 3 pieces, okay, one of those pieces will fit right here. That'll give me my vertical distance. So coming over here, from here to here, I need to divide it into 3 equal pieces. Grab my pencil. 1, 2, 3. Too short, try again. Make it a little longer. 1, 2, 3. Just a little bit longer still. Just ever so slight. 1, 2, 3. It's a little too long. 1, 2, 3. So now I have that third, that 1/3 of the quarter mark to the third, come the same distance over, but now I can see how much of an elevation change that I need. I can erase the X, which was my temporary one, put down a dot. That dot is in the same coordinate position as this point right in here. It's a little brighter for you guys. Right here. That part of the hull of the ship. So for all the CFOS students, it's okay if that doesn't make total sense, okay? Because again, these students have had multiple weeks and many projects to sort this out. How many times have I told you the same thing, students? A lot. You're probably tired of hearing it. But that's the beauty of this class, is that I'm teaching you one concept. You have an entire semester to figure out this one thing, and we're just doing it over and over and over again until it clicks. So all I did is I figured out how far up, how far over. That gave me how far up and how far over. So from here, I just need to go find another point in space. So I think the most logical position next would be to find this point right in here. It'd be the tip of the hull right here. Find the tip of the hull. So we can see it's going to be a little bit farther over, and it's certainly going to be higher up. So in this case, let's figure out how high up it is first, then we'll figure out how far over. So go ahead, let's start by trying to take the unknown. Let's take that vertical measurement there and just see if it fits into anything. Oh, I love when it goes in perfect. Our goal whenever we measure is we want things to fit in as perfectly as possible. If I can find a distance of any size that goes into some other area exactly one time, that's perfect. that has the highest probability of being accurate, because the more we have to move around, the more we have to go 1, 2, 3, 4, any little error we have is going to get multiplied over and over and over again. You might be only an eighth of an inch off, but if I have an eighth of an inch off, and another eighth of an inch off, and another eighth of an inch off, and another eighth of an inch off, next thing I know, I'm at a quarter of an inch or a half inch. And while that may not seem like a big distance, I think people would notice if your left eye was a half inch lower than your other one. You know, I think people might notice. So we want to be as precise as humanly possible. So from the third mark to the halfway point is the distance from the bottom to the top of the hull on the right side. Again, if you can talk yourself through this, that is going to help you a lot. The best way to learn anything is to teach. So teach yourself by talking to yourself. You're an artist, you can get away with it. No one will think you're weird. So I'm capturing the 1/3 to the 1/2, which is the same thing that I had over here. That 1/3 to the 1/2, I just get the corresponding measurement. I come over to the vertical. Again, I don't know the horizontal position yet. I haven't figured that out. I only know how far up, but I know that it's to the right just a little bit. So make a mark, make an X. I know how high this is. Now I need to figure out how far over. That's my next step. Okay, figure out how far over. Okay, so let's figure out how far over this thing. This is quite a large distance, so we're gonna have to try and just see what we get. See if this fits into anything. It's not gonna be a quarter. Oh, yes. 1/4 to 1/3. 1/4 to 1/3, right on the money. Nice and easy. 1/4 to 1/3. We just put this aside, pull our drawing back out. Grab our 1/4 to our 1/3 mark. 1/4 to 1/3. Using the tip of my pencil and the tip of my thumb as a measuring tool. Capture that distance. Come back over here. We know how high it is. We just need to figure out how far over. Feel free to turn your page however much you need to. Align it on that vertical. Make a little mark. It's very faint. You probably won't see it. It's okay. We make a little dot. Okay. And all we've got to do now is just match that curve as best we can. Try not to let your lines get too thick. Try to be nice and precise. And there you go. So this curve here between these 2 points is the same curve throughout here. Yes?
You're going to try to find like a midway point so you can make sure your curve is correct.
Absolutely. And that's an extra layer of detail. Yeah, because remember, whenever we measure, we only trust the points. That's the only thing we would ever count. So if I wanted to use these now as additional measuring tools, I would not use the line in between. I would only use the point. Certainly, if you had the extra time, especially when you get up to these sails, you might start from here to here to here to here and may choose to move on, but it would be a good idea. This is such a large curve, it would be great to find the apex of that curve, which coincidentally is the same as the mast. So if you find the mast, you'll also know where the apex of your curve should lie. So. Absolutely. Now I just want to modify this just a little bit because there's a little bit of a downward dip before it changes direction. There you go. But you can begin to see now the rather significant shrinkage that we have. This box, it seems huge, but it's actually a pretty radical difference in size. So if I go from side to side here and I grab kind of the whole length as if it were a straight line, remember, we never cross the barrier. This is just to show you why you don't cross that barrier. Look at the massive difference from my nail to here. It's almost half. It's almost a 50% reduction. So don't let that box deceive you. Your ship is not going to be anywhere near as big as this ship here. Okay? Any questions about that? So for all the CFAL students, I have a rule in this class. It's called stealing measurements. You never, ever, ever steal a measurement. That would be to take a measurement from one side to cross the gap from page to page and to lay something down. Why would that be wrong? Why would that not work? Well, because just think about it. This is smaller. So just like I showed here, if I were to grab this and bring it over, it's automatically wrong because this is a smaller piece of paper. You could test this too by taking the halfway mark. If I grab half of this paper here, and then show you the halfway point here, look how radical the difference is in sizing between these two boxes, okay? So nothing ever crosses that gulf from left to right. And that's all it is, class. It'll be a little bit of a pain starting out trying to find those first initial points, but remember, the more points you find, the more things you have to measure. Because now my known measurements have increased. Not only do I have all my halves, quarters, and thirds going around, I also have from here to here, 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 and here to here. It's a lot of extra. That's 8 extra measurements now that are entirely unique. Where if I have a measurement that I'm trying to figure out, you know, I'm trying to find the distance of something and I've checked all of my perimeters, it doesn't go in nicely. Now I can come down to the boat and say 1, 2, 3, maybe it's gonna fit into that distance or this distance, okay? So the more of those big shapes you get, the easier this is gonna go over time. Any questions?
Are we drawing everything on the tracing paper?
Yes, all your drawing should be done on the tracing paper. Yep, so once you've traced over your box and you've put that smack dab in the middle of that sheet of tracing paper, you can just fold that up. If you'd like to, probably a good idea to keep it, just kind of set it off to the side, and then just keep working on your tracing paper. If for whatever reason your tracing paper just gets so messy or crinkly or you spill a little water on it, guess what? It's tracing paper. Throw a new sheet of tracing paper on it, transfer all of the good stuff that you want to keep, nice fresh sheet of tracing paper, and you just continue on. Tracing paper is wonderful. I love it. I wish it was like a gallery thing because I've done like really nice figurative work on tracing paper because it's just such a good material. But that's not fine art quality material, so it's not appropriate for gallery usage. But it's just such a lovely material. Any other questions? No? Okay, well, I'm gonna go ahead and end this video then. Thank you so much for listening to How to Draw with Professor Wilson. Did a little bit like Bob Ross. You're gonna draw some happy points. And for my students, go ahead and use the rest of this class period to continue on your drawing. And then for all the CFAL students, I'm gonna come around and let you ask any questions that you might have, okay? All right, you can get to work.